Yeah, so we'll get started. So yeah, this is the first project meeting for the medical LLM project. So yeah, hopefully you guys took a look at the project description already, but yeah, I'll provide a kind of quick sort of intro and so on. But just kind of like also just first of all start out by providing a quick like review of like where like how this field has been moving overall in the medical LM space, and then we'll get to a kind of what we think are some interesting research questions that we want to kind of study and answer, and then we'll talk about like how people can contribute and what we're working on, and yeah, how people can contribute and so on. So yeah, just like to provide like kind of a like a high level kind of like summary of like what's going on in the space. Obviously, in the past few years, people have been really excited by what we can do to improve the medical performance of these language models. You've seen lots of work from Google, OpenAI, many other groups as well. I think right now one of the top models that's specifically designed for medicine was MedGemini. But then on top of that, after these sorts of models that were specifically designed for medical use cases, you have more general purpose models like O3 and GPT-5 that also show strong medical performance, especially when evaluated on some of the newer benchmarks like HealthBench. Even DeepSeek, for example, also does quite well when evaluated on benchmarks like MedHelm and so on. So there's this sort of like also like this distinction between medical specific models and just applying general purpose models to medicine. And that's, I think, also kind of a research question that people are trying to analyze is like, are medical language models better than general purpose models? And there's been a lot of work trying to train if medical language models to get better performance. But yeah, that's kind of like that. This is a lot of this stuff. Like, we had a very simple sort of like SFT kind of work that was happening up till 2024. But then in 2025, of course, then you start to see some of the sort of RL and other sorts of post training methods kind of really take off for medical applications. And by take off, I mean like there's like a few interesting papers. It's still nothing compared to all the other research that's going on. Like there's still a lot of like low hanging fruit, and the space is still pretty undersaturated when it comes to applying RL for medical, medical problems and medical text and so on. So I just wanted to highlight a couple of recent papers in the past year as well. Oh yeah, I guess I had a slide talking about the general purpose RL stuff, which I think is, yeah, I was just talking about it and I forgot I had a slide on it. But yeah, like you can see, like, yeah, like the importance of like RL has been kind of allowing for these general purpose models to actually perform quite well on a variety of tasks. You have the health bench ones. This is with O3. Obviously, even GPT-5 is doing better. So yeah, that's, I think, an important trend going on. But then, yeah, like I mentioned, some people started to look at how can we apply RL uh, to medical tasks. And one of the first papers, or one of the papers I think are quite interesting early on, was this paper from called Guato GPT-01, where they just took a bunch of these question answering tasks and converting them into verifiable problems. And it's like it's a low hanging fruit, obviously, but it is a sort of problem that can be. It's a sort of task that you can turn into a verifiable problem if it's like simple multiple choice, and you can try to see if that improves sort of performance. Of course, it's going to improve performance on the sort of in distribution tasks, but they also test a few out of distribution tasks because they train on data sets like MedQA and MedMCQA, and they also test on MMLU Pro and GPQA, and they see improvement in performance over even some of the other medical language models that are out there in the past. So yeah, I thought this was a paper that was actually published before DeepSeek R1. So I think it was kind of interesting that it was kind of like highlighting the sort of RLVR paradigm before it actually became very popular. So I think that was kind of interesting that this paper got published actually before even DeepSeek R1 was brought the sort of interest in the oral space. So that was kind of interesting in my opinion. But yeah, and then other groups are working on this. Like Microsoft does this very simple experiment, which I've actually been playing around doing similar things recently as well. But yeah, basically, just trying to see if you can you take a small base model and apply RL again on the question answering task and improve performance, and you see the accuracy go up, and also improvement on out of distribution tasks. So yeah, that's something again, just like simple multiple choice can do these sorts of things. But obviously, like simple multiple choice is kind of limiting, and it doesn't really replicate the actual sort of clinical care. I like to say it's like a doctor when they are talking to a patient. There's not like a whole bunch of multiple choice answers that are showing up right next to the patient of like this is the disease that they have, right? Like there's the whole process that the doctor has to go through, asking questions, getting information about the patient, running tests, imaging, and so on. Before they're able to make a diagnosis, before they're able to make decisions about the clinical care of the patient. And this cannot be just like kind of represented in a simple multiple choice question. And so now people are starting to understand that and trying to do evaluations on more sophisticated tasks, and also do RL with more sort of sophisticated environments for medical use cases. So I wanted to highlight a recent paper. This paper was, I think, released like about 2 weeks ago. So it's very brand new. So it's by Xuan M2. So what they did, you can see here, is they created this sort of agentic environment where you have a patient simulator. So you have an LLM that is simulating a patient, and there's some sort of like health record that is associated with it, some sort of reference patient doctor dialogue, and so there's all the information about like a real patient, and then you have an LLM that takes all that information and is asked to act like that sort of patient. And then you have the Dr. LLM, which is what you're training. And that Dr. LLM interacts with this patient LLM. And, the Dr. LLM will have a conversation with that patient LLM and so on. And, you have a sort of multi-turn dialogue. And then eventually the doctor is supposed to provide some diagnosis or some next steps for the patient. And then you have to evaluate that. And again, kind of looking at how evaluations are being done now more recently for some of these open-ended tasks. Again, this group also looks at using rubrics for this sort of thing. So rubrics is kind of now becoming the new trend in the space, because it allows you to try to evaluate something more sophisticated than simple like yes, no, or correct, incorrect kind of verification, but rather there is a rubric for an answer where there are different aspects that you need to evaluate. If you get that aspect, you get a point associated with it, you get some sort of reward associated with that. And if you don't, you get a negative reward for that. And so there's like different things that you want to evaluate, right? You want to evaluate, yeah, like as you can see here in this example, diagnostic accuracy, the empathy of the Dr. LM, and the sort of the communication skills of that Dr. LM. Just kind of general questions. So yeah, like, are they asking the right questions to the patient? Are they making the right decisions about the treatment? You can kind of try to evaluate that in a more fine-grained manner with a rubric, rather than kind of, it's a little bit hard with these sorts of open-ended and more complex tasks. So like rubrics have been kind of becoming not the kind of the craze, not just for like medical LLMs, but kind of more generally with RL for more open-ended tasks. But yeah, it's kind of interesting to see this applied to medicine as well. The thing is, like, rubrics aren't very scalable. Like, how do you, like, a lot of these tools are actually generating, they have rubrics for each individual question, and each rubric will be like, each question will have a different rubric because there's different things to evaluate for each task, each example. And so you have people like looking at a question, looking at a task, and for each of the examples, they actually generate a rubric, they write up a rubric. But also now people are trying to see, can you use AI to actually generate the rubrics as well? This is an interesting kind of approach that I think needs to be investigated further. And like it's again, the thing of course is like it can be more scalable than obviously, having a human expert write out the rubrics, but is it like, you've got this sort of like almost like this sort of feedback loop though that's happening, which I think, it's kind of unclear, how far you can take this sort of like automated rubric generation, then the model's learning on the rubric, and like so on. It's kind of, it's, we'll have to see how well this sort of works in practice, in terms of scaling this up. But yeah, I think it's a kind of an interesting approach that, Baishwan M2, just to be clear, is like not the first paper to try these sorts of things out. There were a few other papers like on the rubric side, like papers like there's a paper from Scale AI that was, talking about rubrics more generally, but they were actually one of the scenarios that they were testing was a sort of was a the medical scenario, and they were using health bench and evaluating with health bench, and yeah, there were a couple other papers as well. So the nice thing about, oh yeah, and then the other sort of things like the sort of whole agentic environment, which is also like not necessarily a new idea. This has been already explored a lot for evaluations kind of recently. So you have papers like Agent Clinic that again do the same sort of thing of like, trying to create a patient simulator for your LLM to interact with, and trying to evaluate models based on that. So there's a lot of research looking into how to evaluate models with this sort of like agentic environment, but now people are starting to explore how to use it for trading as well, and to do RL trading. And that comes to the sort of broader point of like how RL environments and evaluation benchmarks are very similar. They're like, basically the same thing, kind of. It's just like different use cases, I guess, and kind of, but like in a nutshell, you're kind of setting up a similar sort of situation, I guess. Yeah, lots of these things, like, there's been a lot of interesting environments that have been developed for evaluations of medical models, but now thinking about like how to utilize this for trading medical models as well. There's a lot of that's, I think, an interesting research kind of direction that people are starting to explore as well. But yeah, I mean, the Baishuan M2 model was kind of nice. Just kind of took a lot of some of the best, practices so far that people have been observing in the space, and applied it for the sort of RL training. And yeah, they got really good performance. Basically, um, um, like the second best model in medical for medical performance based on the health benchmark. The first being GPT-5, and then you have GPT-5, and then basically this model, according at least among the models that they've tested. But yeah, I mean, like it certainly has beaten a lot of open source models, even a lot of the general purpose models, definitely the medical specific models. So this is, I think, a very interesting result that they had, and kind of interested to see how the sort of research direction goes further. So that's kind of, and then another like kind of like side point that I do want to note, which I think is a little bit kind of understudied, is and I think there's a couple of papers that are starting to explore this further, is like what are we actually doing with this RL training, right? And like how what is the importance of what we're doing with this RL training? Because a lot of people, we're just doing simple fine tuning to kind of just like elicit some medical performance, or add some medical knowledge to these models. But then with the RL stuff, like the goal is now to instead like add some sort of like medical reasoning abilities, because there are some interesting aspects of sort of their clinical reasoning that may differ from what's happening in typical language models. So that's, to me, what I think is important about actually doing the RL training. But there are some results that showcase like, well, a lot of the data sets that are being used are actually like not probably good enough for these sorts of things, because like the problem is like these data sets are certainly very much knowledge heavy as well, in terms of like a lot of the questions that are used in both the training and evaluation data sets are actually just require simple like knowledge of simple medical facts and things like this, and don't actually require sophisticated medical reasoning in order to answer. And so then it's like, yeah, are you really, that's not going to incentivize the RL to train in sort of some of these reasoning abilities too much to significant extent. So there's this paper that I thought was kind of interesting from Stanford, called Disentangled Reasoning and Knowledge in Medical Language Models, where they kind of divide all these questions from the benchmarks and from the training sets into knowledge heavy questions and reasoning heavy questions. And then if you look at the models that have been trained, like these medical RL models, so you have a couple examples here: Med, Reason, Water, GPT, O1, which I just talked about, M1. So there's a few of them that were RL trained models for trying to improve medical reasoning abilities. But if you evaluate them on the sorts of questions that are actually more reasoning heavy, like the performance kind of drops, and there's like still a significant gap that needs to be improved upon. So that's kind of something that's interesting to test out. And then like also like they tested like adversarial robustness. Like if you pre-fill the responses with an incorrect answer to see if these models can reason about that and like get back to the correct answer. These models like often fail to do that very robustly. So yeah, like there's still a lot of like room for improvement on the reasoning ability. And I don't have the result here, but they also like observe like if you add in more of the reasoning questions into your training, that improves the ability, obviously, as you might expect. So I just kind of like highlighting that you want to be careful what kind of data sets you're training on, and that's again this has been true always in AI, and it continues to be true for these RL sort of trading tasks as well. So yeah, so it kind of like taking a step back and kind of looking at like what are some of the research questions that are worth examining at this stage is kind of like, first of all, it's still hard to evaluate these models because even like look at even the benchmarks that I mentioned here, like all these benchmarks that are in this paper, and I think most of the benchmarks that a lot of the other papers evaluate, they're still mostly like multiple choice benchmarks, and there are very few like exceptions to that. Like obviously there's like there is like exceptions like Agent Clinic or Health Bench or something like this, but these are again more sophisticated benchmarks. And so like a lot of people still report like multiple choice question answering evaluations, which doesn't actually represent the actual use cases of these models. And so there's still like a lot of room for improvement on benchmarks. Even benchmarks like Health Bench, like there's still a lot of like, if you look at the data set that Health Bench has and some of the questions that are in that data set, a lot of it is still like not necessarily very representative of what doctors are maybe doing on a day-to-day basis, and if these AI models can help with these sorts of things. So like I still think there's a lot of room for improvement in developing better benchmarks. So that's kind of one area that of course is very important. And then the other area that is kind of also important is just like analyzing like the questions about like what are good tasks to train with RL, what are good rewards to train with RL, what does that look like, what do we get most benefits from. Like some of these papers are doing RL on multiple choice questions and getting quite far, and then there are other ones that utilize like LLM as a judge, utilize these sorts of agentic environments, multi-chart environments. So it's like what do you need to kind of really push the performance further, and like actually kind of comparing and contrasting these sorts of different approaches. And I think that's not been explored as much in the literature right now. On top of that, like a lot of these are like simple, like you're looking at simple text and like a conversation and things like this, but in doctors are also interacting with an EHR software, and sometimes they're doing medical calculations or following specific guidelines and so on. And so like there's a lot of like almost like tool use that is happening also in these sorts of medical environments. And that's another underappreciated area, is like actually can we train these models to do these sorts of tool use set of scenarios as well. And the sort of applications that those enable could also be quite interesting, and that is a little bit underexplored. There are some benchmarks that are starting to explore these sorts of things. A good example is Med Agent Bench, which basically they have like they created like a kind of mock EHR software, and then you can have an agent interact in that sort of mock EHR software and do things, and then evaluate the model based on if it's able to complete the task or not in that sort of EHR software that is created. and that was done to evaluate the models. And of course, they see like a lot of the current models are unable to perform that well in a lot of these tasks. But obviously, you can take maybe this sort of environment that was originally used for evaluation and try to apply it for some of these sorts of RL trading tasks as well. So that's one other thing that I think is quite interesting, and is probably more clinically relevant rather than like actually like practically relevant rather than just multiple choice question answering, of course. And then also going back to this idea of like balancing knowledge versus reasoning abilities. I think that's a very interesting kind of research direction as well, and kind of like what sorts of questions and tasks and like the difficulty and the reasoning abilities that those questions have, and like that what we're providing to these models for training. So yeah, I talk a little bit about this. I talk about this stuff in more depth in like the project description that we have on Notion, and I'll pull that up in a second. Yeah, this is the sorts of stuff that we want to kind of look into overall. So what are we like kind of like now talking about the project itself, and like what are we working on with this project? The 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 simple goal that we have in mind, is basically, yeah, we want to like create a state of the art model. Like that's of course like a very like broad and like a very like basic kind of thing to say, but obviously like that is what we want to eventually do. But in order to do that, there are different things that we need to study and examine, and kind of develop both the infrastructure for, and also kind of answer some research questions surrounding different questions around evaluation, data, and trading. So that's kind of where, like this is what the project is divided into basically. We have a section on evaluation, we have a section on data, and we have a section on training. Evaluation, what we want to do basically is kind of create an automated suite that you can run to evaluate a medical LLM on a whole bunch of medical tasks. That starts out with obviously like simple multiple choice tasks, but also there are more sophisticated agentic tasks that we also want to evaluate on. Things like MedAgent bench that I mentioned, or Agent Clinic, or some of these other ones. So that's something that we want to do. Then on the data side, there's a lot of work that goes into taking a data set and actually processing it for a model to be able to train on that data set. So you want to be careful about things like decontamination, filtering out the data. For example, there are lots of like public data sets that are out there that are like general purpose reasoning traces and things like this, and like synthetic data, for example, and things like that. And like you want to be able to extract some of the biomedical data from these larger corpuses. We want to be able to generate synthetic data that is associated with these biomedical tasks. So lots of things on the data side. Also, again, going back to my point about like balancing reasoning versus knowledge. So like which tests or which examples actually require reasoning? What is the level of difficulty for the reasoning? So there's been a lot of research like that talks about like if you have RL data set, what is the sort of the sort of questions, like if they're easy reasoning questions versus more hard reasoning questions, like does it make sense to like filter out the easy ones versus keeping that in? So there's lots of questions about like this, again, just overall like what kind of data you're putting into the model. So a lot of interesting research that we need to do in that space as well. And then obviously training, it's like that's more of like almost an engineering challenge, less so I think of like I'm not sure. There are some interesting research questions and kind of things to kind of study on the training side, but obviously much of the value is going to come from the data and evaluation, and less on like let's make a slightly better RL algorithm or whatever. But there's still some interesting things to explore there as well overall. So that's kind of what we're doing with the project. Right now, what we've been working on internally is just kind of setting up some of the infrastructure to be able to do some of these model training. But now as we're opening up the project, kind of what we're looking for contributions mostly is more on the evaluation and the data side. So kind of implementing a whole bunch of benchmarks and kind of helping us create this automated suite. That's kind of the near term kind of focus on the evaluation side. And then more longer term is also looking at developing new benchmarks, collecting our own data for evaluation and so on. So that's another aspect on the evaluation front that we want to look into, kind of more on the longer term horizon. And then on the data front, like again, like helping us pre-process the data and kind of label the data in interesting ways, so that when we are kind of studying these research questions about data filtering, about reasoning and things like this, like we have that all prepared in order to do that. So there's, and then also like creating synthetic data sets, all these sorts of things. So that's kind of on the data side that we're looking for contributions on. Obviously, we would be happy to have support on the training side of things too, but that's something that requires a bit more compute, and not many people obviously have experience necessarily with RL trading and things like this, obviously given it's a very new field. And so for us, it's like we're still like diving into this and learning ourselves. But obviously if there's people who want to support, and we're happy to take contributions and so on. And we are talking about all these stuff in the medarc channel. So if people want to check out what's happening in the medarc channel, and we'll be sharing what we're working on the training front, and if people want to help out, they can. But our focus right now for the medarc community is to help out mostly on the evaluation and the training, and the data side of things. So before, so that's kind of, let's see here, I think. So yeah, that's kind of like the overview, but then I want to now like actually pull up some of the first of all, I'll pull up the Notion and talk a little bit about the yeah, just kind of go over the let me just share the Notion screen. So you should, okay, so yeah, the Notion, we have again a description about the project. So again, a lot of this stuff is what I was talking about, but there's some more detail about the actual sorts of things that we can do here. So like evaluation, I have a list of a bunch of different data sets and benchmarks, and kind of like different types of data sets and benchmarks. You have like the basic multiple choice question answering ones. You have some that are a little bit harder, because a lot of these basic ones have been like super saturated by now. Oops, that's not, it's a random AI thing, which I'll have to, yeah. Okay. But what I was trying to say is like a lot of these basic ones are super saturated. The latest models are getting like 90% accuracy. A lot of the main questions that the models are not getting correct are actually errors in the actual labels of the answers and the question answer pairs. So it's like at this point, like are these actually useful benchmarks at this point? Not really as much. They're more, can be used more kind of almost like a sanity check at this point. It's just like, yeah, if the models are performing poorly on these benchmarks, then your model must be complete garbage. That's kind of the level of like, this is why it's still kind of useful to have these benchmarks. But overall, like I think at this point, like it's becoming less useful to have these sorts of benchmarks, in my opinion. Then you do have some harder multiple choice question answering benchmarks, which are less saturated and have been more recently developed. I think all three of these were developed either this year or late last year, and so they're more like newer tasks, and they're more difficult tasks, and they haven't been fully saturated. So if you still want to stick to multiple choice, because that is obviously like appealing because it's very easy to do multiple choice, I would rather use these tasks rather than some of these other ones. Then you have like agnostic tasks that are more open-ended, and basically it's like these are mostly like case study tasks. So it's like, okay, here's a case study where you have a description about a patient, and all the tests that they ran on that patient, and all the imaging results, the patient history, all that, into a nice sort of vignette and a sort of like nice simple description. And then at the end you have to answer what is the diagnosis for that patient. So there's a few examples and tasks and benchmarks that do that. I think that's an interesting sort of thing, that it's a little bit more complex, a little bit more open-ended, and a little bit is closer to what maybe doctors are doing in real life. Because like some of the questions in these multiple choice ones are like basically, yeah, like what is the test you run for a specific patient, like for a specific disease or whatever. Like these are like more, again, knowledge heavy tasks, like as we just kind of discussed before. Whereas the case studies, that's a little bit more complex. You have to like you do more reasoning about how to get to the final diagnosis. So I think this is a bit more interesting task for trading and benchmarking. But even then, obviously, patients don't come in neatly packaged vignettes. So you still aren't, it still has a limitation in that sense. And so it's not going to be like fully representative, but it's certainly better than the multiple choice. Then you have these sorts of which I kind of briefly mentioned already, which try to simulate patient-doctor conversations, and you need to have the doctor basically elicit all the right information from the patients, run the right sort of tests on the patients, and so on. And I think this is like much closer to what is actually important. There are a few benchmarks on this, but still a lot to be explored in that space. And then obviously, then we have more clinical sort of tasks, interacting with EHR records, interacting with clinical notes and so on. That's It's hard to construct benchmarks for this because like clinical notes obviously are like more like harder to get access to, obviously, because of privacy concerns and so on. So there are very little benchmarks in this area, but there are a couple that I think are worth kind of exploring. But then there are other benchmarks like that are not just like what a doctor is doing, but just like more generally what patients can benefit from. So you have like consumer health benchmarks that are answering consumer health questions about that a patient may have for these models, and that's also worthwhile to test. And you want the models to be able to answer simple questions about these sorts of health scenarios and things like this. That the sorts of questions that a patient is like putting into Google or ChatGPT. They're not asking very sophisticated questions per se, but in terms of like you're not having like a full diagnosis that you're trying to do, but you want to like be able to still answer some of these questions. So there are a couple benchmarks for this. For example, MedVet QA is basically taking a subreddit. I think it's called like Ask. Was it? I forget what the subreddit is called, but it's like a bunch of like health questions on Reddit that people have general health questions, and they constructed a benchmark out of that. Then of course you have the rubric-based benchmarks. The main one being Health Bench. Again, this is a bit underexplored, and I think there's a lot to explore there in constructing the right rubrics for health questions. But that's also a kind of really interesting direction as well. So that's the RL, the evaluation side. Then you have the RL side, which again I talked about a bit. Comparing multiple choice data sets for RL versus LM as a judge. Then there's another thing that I think is very important that I think is kind of underexplored and not really appreciated that much. And I've been trying to tell people about this. It's just like it's the importance of distillation. And I think the problem is like people don't understand this because they don't have much, like faculty, most groups don't have much compute, so it's like they can't really explore this sort of thing in much depth. But I think like you have people like saying, hey, we want to train small scale language models, and I think that makes good sense. Like you may want to have like a 3B model that you can deploy on in sort of edge environments, like on a phone or something like this. That can be kind of interesting to have, and can be quite useful in some of these medical scenarios. And so people want to train some of these smaller scale models for medical use cases as well. And to me, I think the wrong way of doing this is actually like creating a 3D model from scratch, or like starting out at the 3D scale. If you want to train small models, you should never start out at the small scale. You should start out at a larger scale, create a large model, and then distill into a small model. And that will give you better performance. Like if you look at what all the big labs are doing, that's what they do. Like when they all train big models and then distill into the small models. And obviously this is hard to do when you don't have compute, but I think it is worthwhile to kind of examine this further. So for us, like if let's say even for a 7B model, if we want the best 7B model, the better approach may be actually to train a 70B model and then distill it into a 7B model. Obviously this can be computationally expensive, but if you actually truly want the best 7B model, maybe that's what you have to do. And so this is something that we want to like explore to some extent. And obviously it can be this can be computationally difficult, and so there's a lot of things that we need to explore and figure out. But that's kind of an interesting research direction that we do also want to eventually explore, and in order to get the best possible models. Okay, and then I'll talk about the trading infra a little bit later. I'll get to that soon enough, but let me just skip over again to the data set side of things. You have obviously like data, like you want to create good SFT data sets. So that's important to do. You want to obviously like train with multiple different environments. That's I think a bit of an open question, and a good research question is like, you have all these different environments. They have different sorts of um, capabilities that you can learn from these different environments. Some are easier capabilities versus others are harder. Like, how do you train on all these multiple environments together, and how do you train on all these multiple tasks together in an optimal way? So that's a kind of interesting thing to explore, that I think is important here. Another interesting to explore that I think not many people have actually explored is like, should general purpose RL data sets be included in the trading? This was a sort of like, has been kind of explored when it came to continual pre-training and SFT, where the conclusion was like, if you don't want the model to catastrophically forget the base model capabilities, you should include a little bit of general purpose data in your continual pre-training or in your SFT to get the best performance, and for it to not like completely forget like how to do general, like actually have like general, regular abilities and capabilities. So is this also true for RL when you're taking like a model and try to specialize it for a specific domain, but you don't want to lose other reasoning capabilities that the model has? Should you include general purpose data sets? That's kind of an underexplored area, I think, as well. And then we've already kind of briefly talked about like filtering based on the difficulty of the task, synthetic data sets, constructing rubrics, human written versus having the AI generate it. Obviously, a big important thing is making sure there's no contamination between the data sets and the benchmarks. So there's lots of things to do here, like in terms of the data set side of things. But yeah, that's kind of like some of the research questions that we want to examine with this project. So at this point, I kind of want to take a moment to go over like the tasks that people could actually start working on. So we do have these different repositories under the medarc organization. Like I mentioned, we're dividing this into three parts, right? We have the evaluation, the data, and the training. So we have three different repositories for each of these tasks. So let me just pull that up. Before I pull that up, maybe it's a good time to like stop for if there's any questions or thoughts on any of these things. Yeah, I'll just kind of stop for that, and then yeah, does anyone have any thoughts on this? Are there any questions about this? Are there any ideas that people have? Yeah. Yes, Abdullah has a question.
Hi, can you hear me properly?
I can. Yes.
Awesome. I have a quick question. So from the data side, how much do you think there's a reliance on maybe creating our own synthetic data sets? So for example, for like GPT-5, there was a mention that they use a lot of synthetic data, right, to train them on in the first place. Do you think it makes sense to make synthetic data on our side, on the data side?
Yeah, I do think synthetic data is going to be an interesting and important research direction for us. I still haven't figured out the best way of doing this, because I think a lot of synthetic data work has been thinking about it more so from like doing SFT, where it's just like, you generate a whole bunch of reasoning traces with a language model, keep the ones that are correct, that give you the right response, and then just basically do SFT on those reasoning traces. And I think that, that's certainly an interesting research direction, lots of good work in that space. And I think it's worth for us to do this. There are actually a lot of good, I feel like actually there are people that are working on generating a lot of good medical synthetic data that I've seen, with GPT-5, with some of the Quen models, with GPT-OSS. So, we may not have to do all this ourselves. There may already be a few good data sets out there. And, we may have to explore that a little bit further. But I don't know how useful the synthetic data also is from like the RL side of things. So I'm seeing it mostly being useful for the SFT. So for that initial SFT phase, yeah, I think we'll definitely have synthetic data in those data sets. Yeah.
Thank you.
Okay, are there any other questions?
So with the reasoning in terms of the SFP data set, have I'm not familiar with the literature, but like, has anyone explored generally using things like, I mean, coming from the background of a medical student, a lot of stuff like answer explanations for board exam questions, things like Google, things like in med school, we use like problem-based learning cases where you like have a case and you like walk through step by step into
Yeah.
anything like that. I don't know to what extent the data set, if any data is incorporated into what's available out there generally, but just that's what comes to mind as definitely what could be a contribution.
Yeah, no, that's a good point, and I think that's a worthwhile direction to potentially explore. And yeah, again, I'm also not as familiar with maybe what data sets are out there that have more um, sort of explanations and things like this associated. Also the question is like, how do you do RL with that sort of thing, or even SFTs? Like, yeah, you have basically you're having feedback associated with it already. Uh, how do you leverage that feedback? Because a lot of these sorts of approaches right now are just basically looking at the final outcome, right? They're looking at the final um, output from the model and utilizing that as a signal for training. But can you also take feedback that you can get on that final output and leverage that for trading as well? That's kind of unexplored a bit. There were like, a lot of like research directions early on in the RL space about things like process-based supervision and stuff like this, where basically you basically have a signal for each step, and you have a reward model that takes a look at each step in the reasoning chain and gives you a reward, and then use that. But that's harder to train because like there's not going to be much data with that. It's also more like it's more computationally expensive to like basically, yeah, you have to go to each step, provide a reward, and utilize that. So it's got some challenges, but like you probably would get better signal and better, it may learn better, but it's just been kind of hard to scale up. So it's more so like, I think it's more of like what you can scale up more easily. And so right now, just this outcome-based supervision where you look at the final uh, output and use that as a signal and kind of just verify that and use that as a signal. It's much easier to scale up, and so that's why people have been able to do that and get a lot of gains with that. But if you found a way to scale up the process-based supervision, you would probably get better performance, frankly speaking. But people have not found a good way of efficiently scaling that up yet.
When you say scale up, do you mean scaling up whatever training process or the RL process, or do you mean sort of like the data set creation?
It's a combination of both. It's like, okay, yeah, data set thing. Yeah, you want to have, because okay, you need enough data, and then basically what you want to do is you want to actually train a reward model on the data, because obviously the data is like a fixed kind of set, right? But in RL, you are actually having the model interact and do things. So you want to actually train a sort of judge or reward that says, okay, taking a look at each step, let me evaluate the step. How is it? What does it look like? Is this model doing well on this step? And then give it an appropriate signal to the RL. So you have to trade that sort of process reward model. So you need enough data to trade that process reward model. And then once you do that, then on the trading side of things, you need to be able to apply that process reward model to every single step. So then it's like a little bit more like computationally expensive on that side as well. So it's a combination of both. But I think the data is kind of certainly bigger factor here. But yeah, I mean, I think it's a combination of both of those issues. But I will preface this by saying, like, or I guess I will just make a caveat by saying, like, I'm certainly not an expert on the process reward or the process based supervision sort of things in that research direction. So maybe there are other aspects that I'm not fully aware of about why that hasn't become as popular. But yeah, there was a lot of research back in like 2022, 2023 in that space. But then that kind of shifted into this sort of outcome-based supervision because I guess people seem to have found that easier to scale up for mainly, I think it's mainly data reasons, but maybe there are other reasons as well. Yeah.
Yeah, gotcha.
Okay. Yeah. So if there are no other questions, I'm going to just quickly showcase like what are the actual tasks that people can work on that we would like, contributions and help with. So let's, okay. So the main one is evaluations. That's what we really want to do. I created this repo. It's obviously like a fresh repo because yeah, we're just getting started. It's a brand new project. A little bit different from some of the other projects where we had like the fMRI and the pathology one, where we already kind of made a little bit of progress internally, and so we kind of had easy like code. We had a code base for people to dive into and stuff like this. This is kind of a bit of like a fresh thing where we're starting from scratch here. So one of the things that we want people to work on, we basically want people to implement a whole bunch of evals. And so how do we implement a whole bunch of evals? So these have a list of evals. You can see like, you have health bench, you have multiple choice question answering. So you have different ones here. This is like an initial set of evals. Like there's still like actually even more evals that, people can probably implement, but these are the ones that are like most important to us right now. So we want people to implement this right now. So how are we going to do this? There are two approaches that we can do this with. The approach that I think is going to be that we kind of are interested in doing right now is basically actually the stack that we have is utilizing the sort of Prime Intellect environments hub. So again, kind of like, let me just talk about like that a bit. So with because the idea is basically we want like a very like very sort of like a very simple suite that you can like automate kind of run a whole bunch of tasks. So what we were thinking of doing basically is I'll pull up the Prime Intellect. So these folks at Prime Intellect, what they've been doing is they have this hub of like people have implementing different environments, RL environments, and you can put it up here, and then it's like very easy for you to basically take an RL environment that's implemented and install them and load them and run them, and you can use it for training RL models. But again, as I kind of briefly alluded to before, RL environments are very similar to evaluations. There's basically an evaluation and a benchmark can be used as an RL environment if you have like I obviously would like to have like a training split and a test split, obviously, if you're going to do that, but basically it's basically the same. And so that's what we want to do here. I mean, you can see like they already kind of have like your evals that like you can take. I guess this one does not have evals. Some of them do, some of them don't. I guess I found a few that don't. Let's see, is there one that does have evals? Yeah, so here, for example, you could do like, evals, where, you take an environment and you can actually apply your model that you want to test on. You test just a model that you want to test the environment on, and you can, get a score that is associated with that. And so this is what we want to do. We want to implement our evaluations as environments in the Prime Intellect hub. And again, this is good for us for a few reasons, because it's like, as you can see, it's pretty easy to use. Like you can then easily just, use the environments, and you can like download and use the environments very simply. And then, we can probably, what we'll eventually do is like say, here are all the environments that are on Prime Intellect that are medical related, and then we'll just have like a script that can just download all those environments and run them and provide a quick automated analysis of all of those environments. So that's kind of what we want to do. And so the way to do this is, like you can see kind of like if you look at, so a few of them have already, some of the simple ones have actually already been implemented, which I put some of them here as like they've been put here, but I just kind of for like just to as an informative kind of thing, but like I would probably have to close some of these issues because they actually have been already implemented on the Prime Intellect Hub. So you can kind of see an example of like what exactly you need to do. But basically this is using the verifiers library to implement these environments, and you can see like, okay, it's like, you have, they're available Hugging Face data sets, and you basically, kind of like, check your response for if it provides the option or not. You have like the different, yeah, you have to, you basically have the data set with, what you want to do is you basically have to prepare the prompt that is associated with the question that you pass into the model, and then you have to be able to take the response from the model and parse it so that you can get the answer. And so you can either parse it directly, if it's like, for example, multiple choice, you can just look for, A, B, C, D or whatever. Or if it's more sophisticated, you could utilize an LM as a judge to do this, for example. And so there's a few examples of that as well. In fact, I also implemented one, which I've put under medarc. So we have already a medarc organization, and so if you're creating new environments, we'll try to put it under the medarc organization. I think that will be a nice place to keep everything available there. And so you could do like, this one is like an example where you need to have an LM as a judge to evaluate, and you can just see, you can create, you have the data set from Hugging Face, you have a prompt, for your that is appended or prepended to the question. So you have the prompt, a system prompt, and then you have the question, and then the model has to respond. You have also a sort of judge template. So this is for the judge to like evaluate. So you see the judge has to takes in the question, the correct answer, and then the response in the model, and it has to evaluate the response in the model. And then you could see like the verifiers library already has like a sort of like API for judge rubrics, and yeah, LM as a judge. And then you can see like you have to extract the answer. And so there's like, you can use, we asked the model to have thinking tags. So you have to just say, okay, outside of the thinking tags, what is the answer? And then you have to like, pass it into a judge. And so, the judge like returns a 1 or 0 at the end. But yeah, you kind of see like the sort of thing that you want to do. And that is how you can create an evaluation environment, but also that can also be used for trading. Like in this case, you can see like we have a nice train split and a validation split, and so we can actually use this environment both for RL trading but also for evaluation. But yeah, we have a whole bunch of benchmarks and data sets that we want to implement, and so if it's not implemented already in this sort of Prime Intellect Hub, this is a good place to start. Is just implement this, and you can take one of these and implement it, and yeah, it's a very simple, I think, kind of place to start. So that's something that we want to work on. Then the other thing we want to work on is on the data set side of things. This is probably a little bit more sophisticated, but is still things that we could certainly use help on. So things like, for example, a simple script that can take a Hugging Face data set like this. So you have like a bunch of like data sets where you have like a bunch of reasoning traces that they've collected for a variety of different tasks. And we want to be able to filter them out for the biomedically relevant ones. And so basically, this is also just useful for like data cleaning and so on. But basically, it's like you want to maybe have like a simple like encoder model that takes in a sort of example and classifies, is it a biomedical example or not, and then utilize that to filter out the data, or at least tags a data point if it's biomedical or not. So that's something that's important as we're trying to filter data for training on. We need to be able to have some sort of code to be able to do that for us. Then also looking at, do you actually need reasoning for this task or not? Or is it reasoning heavy or knowledge heavy? And filtering out examples for that. So you can take a look at how you want to do that as well. And you can take a look at the Biomed R1 paper to see how they do it. They also have some code as well. So they really just kind of have to like make this into a simpler code and kind of clean it up and make a simple script out of it. And then also looking at reasoning difficulty. Can you kind of evaluate how complex the reasoning is for a given data point, and then filter based on that. That's another important kind of question we want to look at as well. But yeah, that's kind of like the sort of different things that we can do on the data front as well that we need help with. And so these ones are more so like, I think we're just going to have like, in this case, like basically 3 different scripts that, if you want to put a PR, solve one of these tasks, we have a PR with a simple, one kind of, one file kind of script that is able to take in a Hugging Face data set and apply the labels to the Hugging Face data set of like, okay, this data point has biomedical or not, or whatever. It becomes like a new column in the Hugging Face data set with that sort of tag or label. And that's kind of a simple sort of thing that we want to do as well. So that's kind of on the data and eval side. We are working on training stuff as well, but it is a bit harder for people to obviously contribute on this side. So we're not like fully expecting people to actually contribute here. But if you want to explore what we're doing on the training side, we do have some code for this, and we're basically right now exploring the Prime RL library, but we're also evaluating other libraries as well. We're looking at Sky RL, we're looking at a couple other libraries as well. The problem is that the RL training infrastructure in the open source space is very brittle. It's very it's still very messy, and so we're trying to find what is a nice, clean, and flexible way of doing things for RL training, and we're still not sure what the right way of doing this is. So right now we're playing with Prime RL, but that may change in the future as well. But if people want to, if people have thoughts that they have on like all these RL frameworks and what they think is easy, what they think is flexible, and so on, feel free to share in the Discord. We're trying to get feedback on this and get people's opinions and thoughts and look into this further. Yeah, we're just trying to like basically get the info up and running for the RL side of things. So that's kind of a nutshell the project, I would say. I know, yeah, we're kind of at time, but I may I'll try to go a little. If you guys have to drop out, that's totally fine. But I'll make a few more things to note. I think we are also kind of working on a bit of like a side project, if you will, which is actually just doing a very simple thing of like, hey, let's take GPT-OSS and fine-tune medical tests and medical data. I say it's a simple thing, but like obviously there's a lot of complexity in trying to get GPT-OSS working. Like a lot of people have been working on trying to get GPT-OS fine-tuning. Yeah, it's like it's still like there's still gonna be a lot of challenges, and so we're trying to see like what we can do. But I think that's a place where like if we can get it working, that would be a fairly easy bit, right? GPT-OSS is one of the best open source medical, one of the best language models on medical tasks. And so if we can fine tune it to get even better medical performance, that would be quite amazing. But there's still a lot of challenges that come into play when it comes to working on creating GPT-OSS, because GPT-OSS is a very weird model too. So yeah, we could talk more about that in the future or discuss in the Discord as well. But that's another thing that we are working on. But again, it's more of a side project. It isn't really part of the main direction, because that's just like a side one-off kind of thing that we're working on, as opposed to the larger research agenda that we have in this MedLM project. But yeah, I think the other thing I'll note is that like we have someone on the Sofont team who is kind of working on the medical LLM stuff, which is Benjamin. He's been kind of experimenting with some of these things this week, and I don't know if Benjamin has anything he wants to add in terms of like what he's been exploring and updates and things like this. But he's mainly been again looking at both like the frameworks for evaluation and the frameworks for training. So maybe Benjamin, you can add a few words about what you've been kind of exploring this week on this front.
Yeah, so I'm Benjamin, new to Sofont, so you might know me as the lead author for Modern BERT, but now I'm transitioning into post-training. So if you guys aren't familiar with how to do post-training at a highly detailed view, neither am I. We'll learn together. So this is pretty exciting. This week, I've just been trying to get speed in the medical environment, RL world, playing around with some of these libraries that Kanish talked about. Let's see, I know something that might be of interest. We're screen sharing on here. So if you just, for example, just want to take a look at what one of these prime RL environments looks like at the end of the day. So this is the first party for math, right? Tanish showed some handcrafted thinking parsers. They have built-in thinking parsers and things of that nature, right? This is just an eval side. So all we're doing is passing in the eval data set. If this was a train, we would pass in a training data set as well. And then when you actually run the command here, I just running this locally against the Hugging Face. This is a small LM3. You know, we'll get some rollouts. We'll get a nice little example so you can see what's going into the model, what this assistant's doing, and then at the end you'll get a little bit of a reward. So these can be pretty simple. They can be a little bit more complex, as Tanish showed us with his example. Unfortunately, the verifiers library is pretty new and it's a little brittle. Like 2 days ago, this wasn't working. Prime Intellect added a bunch of commits and it started working. So all this stuff is going to be pretty new. Same goes for a lot of the RL environments that I'm currently looking at, the Prime RL, Sky RL, and Nemo RL. I guess Nemo is probably the most mature of the bunch, but the rest of them are all pretty brittle, pretty new, and have their own plus and minuses.
Yep. Yeah. So yeah, it'll be a challenge to deal with. Yeah, like some of these. Like, yeah, the RL infra space overall is still very much, it's very nascent still, and there's still a lot of like things that are being figured out. And so most of these libraries are not mature and not in a state like that is like it's not in a stable state, I guess. But we're just gonna have to work with that, unfortunately. But I think, we are trying to, I think the private elect hub is nice, that everything's kind of like in a sort of centralized way and it's kind of plug and play in that sense, assuming the underlying libraries work as they should. And of course, sometimes, they may accidentally, break something, and that happens, I guess. But typically, when it works, it works nicely, I guess. It's kind of, when it works, it's amazing. When it doesn't, it's not.
Like there's some good momentum for the prime environment hubs.
Yes.
If not, Sky RL has their own standard, but they're also adopting the Prime RL standard. So there are some backups if needed.
Yeah, and so the thing is, like, for us, it's not like terribly. It's not also going to be terribly difficult. Like, if you implement in one approach, for us to like convert it to another approach if a better approach comes along. Like, for example, I'll give you an example here. I created that med case reasoning example, and I actually implemented that already previously, as an RL environment or whatever. And then I just actually took the code that I had for that already implemented as an RL environment and passed it to like Cloud Code to say, hey, can you actually make a verifiers version of this? And it basically did it at one shot, and it was not that difficult. It was able to figure it out very easily. So for us, it's mainly like actually just set up the code for it, and like, if it's in verify, like we're starting out with verifiers and Prime Intellect. If something better comes along, you may have to convert it, but it's not too bad. But at least you have a starting point, a reference point for those environments. So that's what it's like right now lacking for a lot of these medical environments. It's like there's no like good code to actually use them. They're mostly like in like research code bases. Like you have a research code base for, hey, let's run this evaluation, and it's like spread across different scripts or whatever. And so we just want like a nice clean place to put it into like a single script. And that is, in this case, we're using Prime Intellect, but we may use something else in the future. But having a good starting point that is easy to use is kind of the kind of spirit of what we're doing here.
And in addition, the Prime Intellect environments, they wrap the OpenAI API, and they do asynchronous calls and all this other fun stuff. It's a little bit of a pain for you to set up manually. So,
Yeah.
We can only be we can be focusing on the important part, which is, getting the evaluation up and running, getting our judges, our verifiable rubrics, that kind of stuff. And then Prime Intellect is handling the tedious actually running it against any OpenAI compliant hub.
Yeah. So we're almost done. I just want to answer a few questions that I'm seeing in the chat, and if you guys also want to bring up some additional questions, feel free to, and then we'll be done. The couple of questions I see here, which I want to answer. So Max is asking, should we commit new environments to the GitHub and then you'll add them to the environment hub under the medarc? Or yeah, that's basically what we'll do. So basically, you can have each evaluation will basically be a folder that you will commit to the GitHub. The folder will, for the verifiers and the Prime Intellect kind of thing that they do, there is basically a sort of you have the .py that implements the environment, and then you also have a PyProject.toml file, which is basically like a requirements file. Because each environment may have some requirements and things like this, so you also have that, and that's also like created when you work with Prime.
It's all UV based, so
yes, the other thing is all UV based
and something modern, so that's good.
Yes, when I started playing around with verifiers, I kind of I was using UV a little bit before, but now I get to experience UV a little bit more, and I'm really liking it actually. So it's it's kind of nice, and I like how they're using it and everything. It works out quite nicely, I would say. So it's pretty nice. But that's kind of what we're gonna do. And then on top of that, I see another question, which is should we create tasks so people do not work on the same task? We will. The way you want to do this is basically you go to the issue in the GitHub. If you're interested in contributing, you say that you want to tackle this problem, and then we will assign that issue to you in the GitHub. And then that way everyone is aware that this person is working on this issue. So that's kind of how it's there won't be a need to have a separate task. We can do this all in GitHub already. So yeah. For data labeling by hardness, how do we define how hard a question is and what scale should be used? So that's a good question. There are different approaches for doing this, and I'm open to different if people want to propose different ways of doing this, and or if you want to look into this a little bit more and propose different ways, I'm open to that. This sort of approach the naive approach that you could take is actually just take a model and run it on those questions, and then basically label it with the reward. So it's almost like you're doing an evaluation, and then you just have the reward for those tasks, and then okay, these are the questions with already high reward that you may want to filter out, and these are the questions with low or medium reward. So that's one way of doing it. The only problem with that is it's computationally expensive. So, because you basically have to run the model on the entire data set. So there may be better approaches, and I frankly would have to look into the literature further to understand that. So if somebody wants to look into literature and propose additional approaches, or look at what other people have done, and they have additional approaches and thoughts on as to how to do this, feel free to do that, and we can discuss this more in the Discord channel as well. But this is the naive approach that I would propose doing. But yeah.
I think that's what one of the papers in the background reading did, right? I forget which one.
Yeah, I think so. That's probably where I got the idea from.
Yeah, they did a subset of the data set, and then they trained a classifier. So I think they used PubMed BERT.
Yes, so that's for evaluating reasoning versus knowledge. So that's one thing. So that's one thing. It's does the question actually require reasoning to begin with? And then the other thing is okay, it requires reasoning. How difficult is that reasoning task? That's kind of maybe the sort of distinction there. So I'm kind of keeping them separate. Maybe you could do this in one way, in in a more unified way, but I think it's kind of useful to help disentangle that a little bit further. So that was kind of what I was thinking of. But yeah, that paper did this sort of thing where they train a classifier, and maybe there are ways of like training classifiers on reasoning difficulty as well, and like you can kind of guess if a question is already difficult just from the question itself, and you have a classifier to do that. And I think there may be work looking into this, but I haven't. I would have to look into this more closely. So if someone wants to like look into the literature for this and propose some ideas in the Discord and before tackling that, feel free to do so. I think that would be really helpful. Okay. Are there any other questions that I want to address? Yeah. Yes.
Yeah.
Hello,
Hi.
JB. Good to see you again.
Yeah, good to see you, and congrats on this initiative. That's amazing. I have a quick question. It's a little bit getting ahead of ourselves, but do you already have ideas in mind of what you intend to release, to publish, the blog posts,
Yeah.
which type of resources, model, demos? Anyways, have you thought about that?
Yeah. So our goal is like this AB model that we're training is hopefully it'll be state of the art. So we will release it, release it open source. We will write up a paper, or I mean, it depends on like how much. Yeah, I mean, we'll probably write up like a full paper for it, and then whoever has contributed. So if you contribute to some of these tasks and things like this, you would be part of that paper. But yeah, that's kind of the artifacts that we would like to release are basically the model, the paper, the code base, and all these sorts of things. In fact, actually, it's very much possible that this also could get divided into multiple papers, depending on how kind of comprehensive these things turn out to be. So, for example, like the language model, the evaluation stuff, right? Like that, it turns into a sort of evaluation suite, which we release as a on GitHub. We could release a blog post associated with it. We could even release a full paper associated with it, because just the evaluation itself is certainly a very valuable thing. And having a place that's like an automated evaluation of language models on medical tasks, that's actually quite beneficial for the community, and it's a useful research contribution. And so that itself could be certainly at the very least a blog post, but potentially even a full paper itself as well. So like there are ways like, certainly we plan to publish papers and release as many of the artifacts as possible. And for the papers, for people who contribute, obviously they would be made co-authors on those papers. Any other questions? Hopefully everything's clear. Feel free to ask me any questions you may have about like what are the next steps, or the some research kind of questions that we're looking at, and kind of the state of what all the different papers and stuff like this. Obviously we'll be in the Discord channel chatting about this, and that's kind of I mean, I'm very excited to start this project. I think this is a project where I think also we are starting very much from the beginning and very much from scratch. So there's a lot of room for people to actually like really kind of shape how this project moves along and goes forward. And I think that there's a lot of exciting things to do here, and it's certainly a very cutting edge. And there's a lot of things that I think we can explore that what we need to, things that we explore in this area that I think can be valuable, not just in the medical space, but to AI and like the sort of like to AI in general, I would say, in terms of like what's happening with RL training and so on. So I'm quite excited about this project, and I hope you guys are as well, and I hope to see some interesting contributions from folks. And I think I guess we'll end it there if there's no other questions. But one thing I'll note is that meeting wise, we are going to have the meetings actually on Wednesday moving forward. So the next meeting will actually be on Wednesday the 17th. So it is actually a little bit sooner than a typical, like these are supposed to be weekly meetings, but the next meeting is actually going to be in 5 days from now. But the reason I did it this week on Friday just because I only launched the project on like Monday, and then like having it on Wednesday is like it felt a little too soon. I wanted to give time for people to kind of like explore and kind of check out what's going on and stuff like this. So I just gave it a little bit of time, and so that's why it was on Friday. But going forward, you'll keep it on Wednesday, because yeah, we don't want to have too many meetings per day for us, because like this is like the fourth project that we've launched. I think we've got a lot of interesting projects on at medarc. So they all have weekly meetings, and we don't want to keep everything like happening all at once. So this meeting will now be held on Wednesday going forward. So the next meeting will be on the 17th. I think it's also good to have this first meeting maybe a little bit sooner than the typical other meetings, because that gives you guys a chance to like, you guys can quickly explore. I'm sure there'll be tons of questions. And so having a time to like a little bit sooner to discuss some of these things will be helpful, I think. But also, if you do have questions, just feel free to ask them in the Discord as well. Like, you don't have to wait until the meeting to ask your questions as well. So like, I know that some people like may prefer to discuss things in a meeting and things like that, and that's helpful. But also feel free to just ask the questions in the Discord so that we can like move along things quickly as well. So yeah, great. Well, I don't know if like Benjamin, you want to add anything else? Paul, you want to add anything else? If not, yeah, I
think
know
we're
also this
pretty
meeting.
comprehensive.
Yeah, yeah. I mean, I think it's a very comprehensive project. It is a huge undertaking. There's a lot to explore. So I wanted to provide kind of a big overview of everything, and looking forward to working with all of you guys on these projects. So, yeah, yeah. Someone was asking a question about like if
Sorry, I just snuck in a question last your last minute. Apologies. But the
no,
question
that's
was
fine. That's
basically
fine.
like,
Yeah.
yeah.
Yeah, I see the question. Yeah, like looking at like if different comparing different encoders and things like this, and if that could be a paper too. Yeah, like there's lots of things that like could be turned into a paper. That is certainly something you would want to like test out as different encoders and stuff like this. May not necessarily also be like the full paper. We are also like may want to do like blog posts and things like this. Or maybe it's like not a full paper but a workshop paper. Like there's different things of like exploring. But generally, the idea of what we're doing is whatever research contributions we want to make, we are going to publish them in some way, in some format or another. So if you're making a research contribution, we're going to make sure it gets out there and people are going to see it. And that is certainly, what we want to do here. The exact format depends on the exact sort of research contribution and what we're doing. But yeah, that's the sort of general sort of mindset that we have here at medarc. Yeah. Okay. Well, I know this went a little bit of overtime, but I think that's because we had a lot to talk about from the first meeting. So I'm glad that you guys all stuck around. But yeah, I guess I'll see you guys all on Wednesday, and also I'll see you guys in Discord as well. So yeah, thanks all for joining.